A very good day to all. I am Dr. Rizwana Begum, and in this session, I'd like to discuss diagrammatic and graphic representation, and we shall look into some more illustration on location of mode through histogram. We have seen in the previous sessions how to locate mode graphically. Some of the illustrations we have already seen. We'll look into some other illustration. Here, the information given is draw a histogram and locate mode graphically from the following data. So here, in this problem or in this illustration, instead of class intervals, mid values are given or mid points are given in the problem, like 15, 19, 23, 27 and 31. And frequencies are 6, 10, 20, 15 and 4. So when we do this solution or before plotting histogram, what we have to do is we should convert this mid values to proper class intervals. How to do that? And we have seen these conversion from mid value to class intervals in different types of problems, like in the measures of central tendency or measures of dispersion. Wherever it is, whenever mid values are given, we convert into class intervals. So we just have to look into the difference between the mid values. There is 4 difference: 15 minus 9, 19 minus 15, 23 minus 19, 27 minus 3, 31 minus 27, like this. So what we have to do is we just have to take the half of that and add to the mid value and deduct half from the mid value. Like this, we will get lower limit and upper limit of the class interval, like 13 to 17, 17 to 21, 21 to 25, 25 to 29, 29 to 23. So once we are done with this, and we have to see that our class intervals and frequencies are proper, because in other problems also, if uh, less than frequencies are given, we have to convert into proper class intervals, and if more than class intervals are given, we should convert into proper class intervals by adjusting the frequencies in both less than and more than. Then if inclusive class intervals are given, we should convert into exclusive class intervals, and these rules apply here also. So while we construct histogram, or before constructing histogram, we make sure that class intervals are proper to be plotted in the graph. So here in the x-axis we have class intervals, and in the y-axis we have frequencies. So if you just look here, that is first frequency or first class interval 13 to 17, frequency is 6. 17 to 21, frequency is 10. 21 to 25, frequency is 20. 25 to 29, frequency is 15, and 29 to 33 should have been, okay, 29 to 33, 4. And as we know, we should locate the mode here. So here what we do is, which is having highest frequency, that is with the bar which is having, or the histogram which is having highest frequency of 20 here, this one. So from this point to the next bar or next bin here, first point we have to join there, then of this here from this point to the previous bar, and intersection point of these two perpendicular line. When we put into x-axis, this m value is a mode or OM, that is 23.6 we get here. So this is how the mode is located through histogram. Hope this is understood here. Then next illustration, if you just see, that is draw a histogram for the following and find mode by graphic method. So here class are given here. So class from 100 to 110, 110 to 20, 120, 120 to 130, 130 to 140, 140 to 150, 150 to 160. Frequencies 8, 12, 30, 18, 14 and 6. So there is no problem with regard to class intervals. So we plot it in the x-axis and y-axis. X-axis we plot the class intervals. 1 centimeter is equal to 100 units, and we have taken frequency in the y-axis. So 1 centimeter is equal to 4 units. So we have plotted here 100 to 110, that is 8, 110 to 120, 12, 120 to 130, 30, 130 to 140, 18, 140 to 150, 14, 150 to 160, 6. So we have plotted this and we have drawn the histogram by taking equal width of the bar and by not keeping any gap between the bars. And now it's time to locate the mode. So we just look into the bars here. So histogram here, when we look into this, we find that 120 to 130 class interval, which is the 30 frequency, is the lengthiest one, and we should locate mode here. So from this point to the next bar's first point, and from this point to the next previous bar's last point, where it touches this points, so it touches these bar or the frequency or highest frequency bar, and we draw the line here like this, and the intersection point here we get, like if we denote it as O here, then from this to x-axis a straight line or perpendicular line, this OM, and here we identify the value M. So here in this illustration, mode value is 126. Hope this is clear to you. Thank you.